solving and writing division equations. So we've done addition, subtraction, multiplication, and now we're doing division. And if you remember, when we were trying to solve for the variable, if it was addition, we subtracted. If it was subtraction, we added. If it was multiplication, we divided. So what can you think if it's division, we're going to multiply? You do the opposite, okay? So I have a divided by 3 equals 7. So I want to get a all by itself. It's a divided by 3. So I times 3 times 3. And 3 divided by 3 times 3, those cancel each other out. And so I get a equals 21. Now let me make sure this is okay. If a is 21 divided by 3 equals 7. And that is true. Okay. Now with this one I could have written it like this. A divided by 3 equals 7. A divided by 3 is the same as saying a divided by 3. It's the same way. So we come here and we have m divided by 5 equals 9. So it's divided by 5. We're going to times 5 times 5. Divided by 5 and times 5, those cancel each other out. So you're left with m, and then equals 9 times 5 is 45. Okay. And I want to show you how these cancel each other out. So m5 times 5. M times 5, I want to get this into a fraction, so it's m times 5 times 5 over 1. So it's the same, this is the same as this. Now, I can cross reduce, that becomes a 1, that becomes a 1. Then I have m over 1, okay? Or, if I don't reduce, if I don't cross those, I go ahead and multiply it, so it's 5m over 5. And 5m over 5, I can simplify that. This becomes a 1, that becomes a 1, it becomes m over 1, and m over 1 is just m, okay? So that's how the division and the multiplication, they cancel each other out. All right, let's go to some word problems. The key, though, over here is that when you see it's divided by, either written this way, a divided by 3, or a divided by 3. Either way that that's written, you want to do the opposite. You want to times it by 3, times it by 3. The divided 3 and the times 3 cancel each other out, and you're left with just the variable. Okay, let's do this one. Weight of an object on the moon is 1/6 of its weight on Earth. Okay, so if it's 1/6 of its weight on Earth, we have, okay, we have the moon there, we have Earth here. This is going to be heavier, this is going to be lighter, okay? Because it's 1/6. It's just 1/6 of the weight on the moon that it is on Earth. Why did I do an H there? I have no idea. And, oh, because I did heavier on Earth. Okay. There you go. So heavier on the Earth, lighter on the moon. Okay. So we know that just it's 1/6 of the weight on Earth. So if I have something here that weighs so many pounds, it's going to be 1/6. It's going to be a lot lighter. So let's see. If it weighs 35 pounds on the moon, so I have 35 pounds here. I want to find how much it's going to be here. It's going to be a lot heavier, okay? Because this is 1/6 of this. So I don't know how much it's going to weigh on Earth. So we'll do E for that. E, which I don't know, times 1/6 equals, I know it's 35 pounds on the moon, 35 pounds, okay? So if I know what it weighs on Earth, I'm going to times it by the 1/6, and that'll get me how much it weighs on Earth, okay? So if I do this, I can go like that. You can put a 1 under a variable. So then I do 6 times 1. I mean E. E times 1 is just E because it's 1E. 1 times 6 is 6 equals 35. So now we have E divided by 6 equals 35. I want to get this E all by itself. So it's divided by 6, so I have to times it by 6, times that by 6. That cancels each other out. So I have E equal 35 times 6. 35 times 6, 30, let's see, that's 18, 19, 20, 21. Okay, E equals 210 pounds. So something that weighs 35 pounds on the moon will weigh 210 pounds on Earth. I'm pretty close to 200 pounds myself. So if I want to lose weight, I could either exercise and eat healthier, or I can go live on the moon. I don't know which is going to be easier. They're both hard. But 35 pounds on the moon. So 210 pounds on Earth is 35 pounds. And the way I'm going to check that is I'm going to do 210 times 1/6 equals 35. I'm going to put this under 1. 210 times 1 is 210. 1 times 6 is 6 equals 35. I'm going to see if 210 divided by 6 equals 35. 6 goes into 21 7 times. No, not 7 times. 3 times. 3 times 6 is 18. And then that becomes 3, bring it down by 0. 6 goes into 35 times, and it is 35. So it is accurate. Okay. So my division E Earth divided by 6 equals 35. There's a division equation. And then when I solve for E, because it's division, I multiply both sides by the same. Okay? All right, let's do this last one here. Carla is buying ribbon, and she's doing it for costumes. She wants to divide the ribbon into 8.5-inch pieces for 16 costumes. Okay? How much ribbon does she need? So a part of me looks at this, and I could write this just as a multiplication problem. Well, she's going to have 16 costumes, and if she times it by 8.5, that'll tell me how much ribbon she needs in total. Okay? So it could be 16 times 8.5. Then you don't have a variable. Well, your variable will be, let's see, we'll do M for material, or R for ribbon. Okay? So 16 times 8.5 equals R, equals how much ribbon. Let's do this a different way, because we want to set it up as a division one. So we don't know how much ribbon she needs. Ribbon, total ribbon is the question. Okay? So if I take my total ribbon and times it. I'm going to divide it. If I take my total ribbon, I divide it by 8.5. So my total ribbon is like, it's a long, long piece of ribbon. I don't know how much it is, but it's long because I need it for 16 costumes. And once I have this long, long, long piece of ribbon, I'm going to divide it into these 8.5 slices. So I take my long ribbon, divide it by 8.5, and that's going to allow me to have 16 costumes. Because I need enough long ribbon divided 8.5 ways for 16 costumes. So if I take my ribbon, divided by 8.5, I will get 16. Now I got to figure out what R is. I want to isolate, get that R all by itself. R divided by 8.5, the way I'm going to get rid of that 8.5 is do the opposite, times it by 8.5, times this by 8.5. Those cancel. It's going to give me R equals, and look at 16 times 8.5, which is where I originally started. Okay, but you set it up as a division so that it can get you the answer. But let's do this. 16 times 8.5. Multiplication ones, you don't have to line up your decimal. You could use your calculator, or you could just do this by hand. 6 times 5 is 30. 5 times 1 is 5 times 3 is 8. Add my 0. Then I have 6 times 8 is 48. 8 times 1 is 8 plus 4 is 12. Then I have 8 plus 8 is 16. Then 1 plus 2 is 3. And then 1. Now I come out 1, go in 1. So what I need is 136 inches of ribbon. 136 inches of ribbon. Now, let's make sure that makes sense. Carla's buying ribbon for costumes. She wants to divide the ribbon, the total ribbon, into 8.5-inch pieces for 16 costumes. Okay, so if I take this 136 inches of ribbon I think I have, if I take this and divide it into 16 costumes, I should get 8.5. Or if I divide 136 into 8.5 pieces of ribbon, I should have 16 pieces that's going to be good for 16 costumes. So this R divided by 8.5, so 136 divided by 8.5 should equals 16. And I know that I could do it on my calculator, I could do it on the board, but I know that it is going to work, and that will be a true statement. So a total ribbon is 136. Okay? I think these are fairly straightforward for you. It's when you start to put things into words and have to figure things out, you always want to, with these word problems, is ask yourself what makes sense. Okay? So like on this one, we know the moon is going to be 1/6 the weight of something on Earth. So if it's asking for me, what's the weight of something on Earth, it's going to be heavier than on the moon. If it's asking for me to tell me something that's on the moon, it's going to be a lot lighter than on Earth. So you got to say, okay, 35 pounds on the moon, well, something on Earth is going to be a lot heavier. So when I get an answer of 210, I think, okay, yeah, I'm in the right ballpark. And then with this one, ribbons, 8.5 pieces for 16 costumes. I know that if I get like a number like 2, 16 divided by 8.5 is going to be 2 something. So I need 2 inches of ribbon to be able to divide that for 16 costumes to get 8.5. It just doesn't make sense. Okay? And sometimes you have to read it a couple times. Sometimes you got to underline things. Keep working at it, whatever it takes.